Imagine walking into a room where people are playing chess, but you don't know the rules. You only see strange moves on the board, and nothing makes sense at first. You sit on the floor and quietly watch the pieces move again and again. Slowly, you begin to notice small hidden patterns in those moves. You see that each chess piece seems to follow its own special rule. You make your first little guess about how one piece is allowed to move. You keep watching as the same moves repeat and repeat like a pattern. Now you smile, because you have finally learned one small rule of the game. Physics also begins like this, with a student watching an apple fall from a tree. You look up at the sky and see a bright, colorful rainbow after the rain. You notice a beam of light bouncing perfectly from the surface of a mirror. You watch glowing electric current flow through a wire and power a device. You take a notebook and carefully write down all the things you have seen. Around you, many events from nature float like icons in your mind. There are still no formulas, only careful looking and patient watching. Soon, clear patterns appear, like objects always falling straight downward. You see that heat always flows from a hot object to a colder one. You see that light usually travels in a straight line through the air. You notice that every dropped object keeps falling down towards the ground. Scientists use these patterns to guess simple rules, like teachers of nature. But every rule they write is still only their best guess, not final truth. Long ago, Isaac Newton studied light and tried to understand what it really is. He decided that light must be made of tiny particles flying in straight lines. These light particles even bounced from mirrors like tiny balls. Many people agreed, and students watched these ideas with great respect. The rulebook of physics loudly said, light is a particle. Then Huygens came and said, no, light behaves like a wave. Many scientists around him looked doubtful and did not trust this idea. So a very careful experiment was prepared using a beam of light and two slits. The light passed through the two tiny slits in a thin wall. On the screen behind, a beautiful pattern of bright and dark bands appeared. The pattern looked exactly like waves, so the rule changed to, light is a wave. Later, scientists shone bright light onto a clean metal surface. To their surprise, tiny electrons flew out of the metal like sparks. But sometimes, even very bright light could not push any electrons out. Only high-frequency light could knock the electrons free from the metal. Max Planck then said that energy comes in tiny packets, not in a smooth flow. Albert Einstein thought deeply and used this idea to explain the effect. He said that light is made of energy packets called photons, like tiny bullets. Once again, light looked like a particle, and the puzzle grew stronger. Students now felt confused, with waves and particles mixing in their heads. Then they Broglie asked, if light can be both, what about matter like electrons? He suggested that even an electron can behave like a wave. Experiments showed interference patterns made by electrons, just like light waves. So scientists saw that everything in nature can act as both wave and particle. Einstein did not like this strange randomness in the new quantum rules. He imagined the universe as if someone were throwing dice to decide outcomes. Later, Stephen Hawking said that some of nature's deepest rules may stay hidden. Nature began to look like a great chess player, quietly making clever moves. And we are still learning the rules of this beautiful game, one small pattern at a time.